Hello class, we're about to start topic 8, the complement rule. We have complement of an event. All the outcomes that are not contained in an event. So for an event E, the complement written E to the C is everything not E. So that's E complement. And then example 1, state the complements of the following events. Experiment, rolling a 6-sided die. Event E equals rolling an even number. So what would be the complement, which we would put E, complement, that would equal to rolling an odd number. Because there are only two types of numbers on the die, it's even or odd, and since the event is rolling an even number, the only thing left is to roll an odd number, and that would be the complement. Okay, B, we have experiment, selecting a person at random. Event F equals having AB blood. So we'll do the complement of F, which is not having type AB blood. Now we come here to C. It says experiment, selecting a card at random. Event G, selecting a spade. So the complement of G will be not selecting a spade. Now we come here to D, the weather report. There's a 20% chance of rain today. Now we know whenever we're dealing with percentages, typically when we hit 100%, there's typically nothing else, but we know of situations where we could go above 100%. So if it's 20% chance of rain here, then that means that the complement of this situation would mean that it's 80% of not rain. So that will cover 100% of the situation, 20% of rain, 80% of not rain. Okay, now we come to the complement rule. If E represents any event, then and E complement is a complement of E, then the probability of E complement is 1 minus the probability of the event. In words, E complement is everything not in E. So everything outside of this circle of E or this Venn diagram of E is the complement. Now we move on to example 2. It says the following probability model shows the distribution of age groups for donors at a recent blood drive at the Red Cross. You are going to randomly select one of the donors. Find the probability that the person is a legal adult using the complement rule. Okay, so basically we have our age group, which is less than 18, and all the rest of them are 18 and over, which means they are adults. So to find the complement, we take the complement of E, and we would set it equal to 1 minus the event happening. Okay, now, complement of E should be 1 minus. Now remember, we want to find that the person is a legal adult. So what we would do is take 1 minus the age group that's under adulthood, which is this less than 18 group. So the probability is 0.06. And the complement of this event would be all legal adults. So 1 minus 0.06 would be 0.94. So that is the probability of a legal adult fit in this situation. Okay, now we come here to example 3. It says again, let's consider our two-way table for students, gender, and eye color. Now we have blue eyes, brown eyes, other, and total. Okay, so what we're going to do is this here. We're going to take these values here that we previously put in. These are, let's put these values in. 6, 11, 22. Okay, these are values we put in a previous lesson. It says, find the probability that a randomly selected person in the class does not have blue eyes. That is, find P of blue complement. So we want all of the people that do not have blue eyes. So we'll have the probability of the complement of blue, which would be 1 minus. Now, we must first find the blue-eyed people. So what we would do is go off to the side, and we would do the probability of blue eyes based upon this table. Now, there are, of the people with blue eyes, there are 6 people with blue eyes, but there are a total of 22 people. So we would take the amount of people with blue eyes divided by the total amount of people. So 6 divided by 22 will give us approximately 0.27. So we would take 1 minus 0.27. We're taking 1 minus the probability of people with blue eyes, and that would give us 0.73. And that will be our final answer. That will be the probability of a person without blue eyes. Now we scroll here to example 4. It says, in a nursing class, there are 10 sophomores and 20 juniors. 5 of the sophomores are males, and 10 of the juniors are males. If a student is selected at random, find the probability that the student is a junior or male. Okay, so we want to take the probability of being a junior and also the probability of being a male. Minus, we have to get rid of the overlap, which would be the probability of both. So, the probability of being a junior would be 20 out of 30 people. As we stated here, it's 10 sophomores, 20 juniors, so that's a total of 30 people. And we're told here that 5 of the sophomores are males and 10 of the juniors are males. So what we have here, we have 20 juniors over 30 plus. Now we come to the probability of males. So it's 5 males that are sophomores and 10 males that are juniors, all divided by 30. Because it's still a total of 30 people, minus the probability of both. Now, we're looking for junior or male. So we know 10 of them are juniors and males, so we'll subtract 10 over 30. Now, we have 20 over 30 plus 15 over 30 minus the overlap, which would be 10 over 30. So that would be 35 minus 10, which would give us 25 over 30. Okay, 25 over 30 will give us approximately 0.83 when we round to 2 decimal places. So that will be our final answer. Now, we come here to B. It says the next situation is a sophomore so we have the probability of a sophomore plus the probability that they're female. And then we have to subtract, but the overlap happens where they fit both criteria. Okay, the probability of a sophomore, there are 10 sophomores based upon the direction. So it'd be 10 over 30 because it's a total of 30. The probability of them being female, it tells us in the directions here that it's 15 females. And it's 15 out of 30. Okay, now, because if you look back up here, just to clarify this, it's 5 males that are sophomore and 10 males that are juniors. So that's a total of 15 males. So the only thing that's left is female, which would be the other 15 of the 30. Now we want to subtract both. And there are 5 females that are both sophomores and female. Okay, so now when we add all of this up, this will end up giving us 20 over 30, which would give us approximately, if we round to 2 decimal places, 0.67. And that is our final answer. Now, we go to the next page. It says, example 5, you are selecting a single card from a standard 52 card deck at random. Find the following probabilities and unreduced fractions and decimals, rounded to 4 places. It says, find the probability that you select a card that is an ace or a king. So we add a probability of an ace plus the probability of a king minus the probability of both. Okay, so now the ace, we have 4 out of 52. There are 4 aces. The probability of a king will be 4 out of 52. And then the probability of both, which would be 8 out of 52. Oh, wait a minute, I made a slight error here. This is actually what this is equal to, because there's no probability of picking one card and getting an ace and a king, because these are 2 separate type of cards. So there's no way you would have both, so we wouldn't have to subtract off anything. So we have 4 over 52, and 4 over 52 is 8 over 52. And we can round this to 4 decimal places, which would give us 0.1538. And that would be the probability of getting an ace or a king. Now we go to B here. It says find the probability that you select a king or a heart. So we have probability of a king plus the probability of a heart minus the probability of both. Now the probability of a king is 4 out of 52. The probability of a heart is 13 hearts out of 52. And the probability of both it being a king and a heart is 1 out of 52. Now after we add and subtract here, we will get 16 over 52, which rounds to 4 decimal places of 0.3077. 0.3077. Okay, and that's the final answer for B. Now we come to C. It says find the probability that you do not select a face card. Now first of all, you have to know what face cards are. Face cards are basically your king, queen, and jack. Those are all the cards that actually have faces on it. So we have the probability of the complement of the face cards. So it'd be 1 minus the probability of the face cards. Or you could just put F. So it'd be 1 minus, it's 12 face cards. So it'd be 12 over 52. And when you take 1 minus 12 over 52, that'll give you 40 over 52, which rounds to 0.7692. That is the probability of not selecting a face card. Okay, now we come down here to example 6. It says a theme park's marketing department calculates the probability that a family will visit the Safari Zoo on their trip to be 0.65, and a probability that they will ride the tourist railway on their trip to be 0.55. Moreover, they calculate the probability that they do both things during the same trip to be 0.43. Calculate the value for P of zoo or REL, fill in a diagram with the appropriate probability values to illustrate.